Hello and welcome to this session of Grade 7 Mathematics. In this session, we'll be exploring the symbols less than, more than, less than and equal to, more than and equal to, and how they are being used. I am Hiralal Baljor. Do enjoy. In mathematics, there are key terms in which we should be using. Now, it is not always about equals. Sometimes we know that something is greater than or less than. The two most common inequalities are the more than sign or the greater than sign. Take for example, 5 is greater than 2. The less than sign, we could say 7 is less than 9. Now how do we identify the less than and the more than? A practical example is the easy way. The small n always point to the small number. So take for example, look at my hand here. This should be big number, this is small number. Other example, this is big number, this is small number. Another key term there is the greater than or equal to. For example, x is greater than or equal to 1. And later when we explore these options, we will see what exactly we mean by greater than and equal to. Another symbol or another key term that we use in mathematics is the less than or equal to. For example, y is less than and equal to 3. Like I said before, we're going to explore what do we mean by less than and equal to or more than and equal to. Look at this example here. Alex and Billy have a race and Billy wins. What do we know? We don't know how fast they ran, but we do know that Billy was faster than Alex. So, how do we write this? We can write this to say Billy is greater than Alex. Symbolizing it means B is greater than A, where B means how fast Billy was. The greater than sign again, remember the symbol? The big side pointing to me, the small end pointing towards a smaller number. And A means how fast Alex was. Another example, Alex plays in the under 15 soccer. How old is Alex? We don't know exactly how old is Alex because it doesn't say equals. See the example? Let me repeat that again. Alex plays in the under 15 soccer. How old is Alex? Now, we don't know less than 15, but we can write age is less than 15. Look at the small end again. The small end points to age because age is smaller than 15. Therefore, Alex is less than 15. Another example. You must be 13 or older to watch a movie. And we have all experienced this, haven't we? The inequality is between your age and the age of 13. Your age must be greater than or equal to 13, which is written as age is greater than and equal to 13. Let us back up and look at the example again. You must be 13 or older to watch a movie. It means at 13, 14, 15, 16, you are privileged to watch a movie. If you're 12, can you watch a movie? Absolutely not. The meaning of the inequality, and like I said early on, we need to give meaning to what we say of an inequality. Now when we say x is more than 10, if you were to put that on the number line, you'd have noticed several things there. You would have seen the circle over 10 and the arrow going towards the negative side or less than 10. If you were to put this on the number line, you'd have noticed we have an indicator over 10 and the arrow pointing towards the value or the values less than 10. There's a key point. You would have noticed the indicator or that circle over 10 is not shaded. Why? It's not shaded. It means the values are estimated around 10 but not including 10. If you were to represent it on the Cartesian plane, you'd have noticed I put x and there's a broken line across 10. That broken line has significance. What is the significance? It takes value up to 10 but not 10. 10 is not included. The arrow's shading shows that the values are less than 10. If you were to list the set of rational numbers, and here is where it gets interesting, you'd have noticed the set of numbers less than 10 would have been from 9, 8, 7 going towards infinity. So there you have a representation there in 3 different domains of how we represent an inequality and give meaning to it. Let us try another example. X is less than or equal to 10. What do we mean by x is less than or equal to 10? You would have remembered in the previous example we had x is less than 10. And what do we mean by x is less than 10? You would have looked at the indicator there. You would have noticed that we had the indicator over 10 to show that it's an approximate value of 10. However, in this case here, when x is less than or equal to 10, you would have noticed the indicator is being shaded, meaning that 10 is included there. The arrow going from values of 10, 9, 8, which is less than 10, towards infinity. On the Cartesian plane, there we go again. You'd have noticed the line, which is a solid line drawn through 10, meaning that 10 is included. For the inequality, x is less than or equal to 10. All the values that are less than 10, including 10, are shaded to show that representation. And there we have the set of rational numbers where you would have seen x is less than 10, less than or equal to 10, meaning 10 is included, 9, 8, 7 to infinity. So let us get into some practice activities capturing the inequalities that we have learned early on. That is the less than, more than, less than and equal to, and more than and equal to. Let us give meaning to the following inequalities. X is greater than 7. Y is less than 9. X is greater than and equal to minus 4. I want you to remember what we have said. The inequality sign, where the big side is pointing to, it is the largest number. The small end points to the smallest number. So having gone through that today, I hope you had fun. As I see you again for the next session, we will be exploring more mathematics concepts.